All right, cool. So it's a 25-minute slot, and I'll have to go a little bit fast, a little bit quick on introduction, skip over a couple things, and just to let you know, there's a lot more on this to talk about. So if you're interested in discussing other strategies or other scenarios, I'm more than happy to meet up afterwards if you want to chat more. So briefly, I'm Josh Stone. You can find me on the internet. Have been to DerbyCon before. It's my second year as a speaker. Really love it. Becoming my favorite conference of the year. I work for PSC. So PSC is primarily a PCI company, and we do a number of different things, but my particular piece of it is penetration testing. So always looking for the 16-digit numbers. What it means is I usually end up in environments that look a little bit kind of like this, where we've got a company with a whole normal corporate network, but there's a particular subset, some piece of it, which is the PCI network, and that has to be segmented and protected differently from the rest of the environment. So we end up with a lot of interesting scenarios where somebody has made attempts to segment that zone separately from the other pieces, and gives us a lot of interesting pen testing challenges. So today I'm specifically talking about MFA, and I'm going to kind of assume that pretty much everybody knows what multi-factor is. Just very briefly, I'll talk a little bit about it. Multi-factor is basically any time that you need something more than just a password to log in. So you might have something like this hanging off your keychain. It generates a random number every 30 seconds or something like that. Or maybe you forgo that and you have an app on your phone, something like that. There are a bunch of different designs, different architectures. Break down into a couple major types, and I'll show a couple examples today about practical attacks against them. The main take-home for the pen tester, and probably for the evil intruder, is that, oh dear, I'm not getting all my slides on. All right. So with MFA, getting a password is not enough all by itself. You have to get a little bit more than just the password. So a lot of times if we get an escalated position in the network and we start cracking hashes that we found, or we mimikatz and get a bunch of passwords off of somebody's box from their LSAS, that's not enough to get past the MFA, and that's what makes it very interesting. So a lot of networks that are porous without MFA become difficult. So I'm talking about practical MFA attacks, and by that I don't mean that I'm talking about finding an isolated 0 day against an MFA application or infrastructure. I'm talking about attacking multi-factor in its context, where it lives in the network. So I'm talking about a particular scenario, and I just want to make it really clear so I'm not overstating or somehow over-embellishing something. There are a lot of other scenarios that we could talk about. This is just the one that's particularly important to me. So I thought it'd be good, in order to set up the scenario, to develop a picture of what the pen test... Wow, is there any way to make that better? Hold on. Oh yeah, is that possible? That would be awesome. Is that getting more of... No, it's not. Oh dear. Hold on. Yeah, I will. No. That's unhappy. What if I mirror? I won't get my pre-slide, but maybe that's better. Oh dear. There's no reason the adapter would make a difference, right?
Not really, no.
Oh man.
You'll have different resolutions.
It's picking it up on the video, it's just not picking it up on the
Okay, you know what I'm going to do, actually? Yeah, I'm just going to keep it on there, and you guys will see ahead. I'm sorry. It won't be as dramatic. Let's see. We will make do.
Move the sidebar over.
Yeah. All right. Sorry for the delay. All right, so. Uh-oh. No longer mirroring. Okay, so hopefully that'll not drive me too nuts. All right. So I want to build a picture of what the pen test looks like without multi-factor, and that'll help you see what what changes when we throw multi-factor into the mix. So I plug in the internal network, and I'm going to use some low-hanging fruit. I'll find an initial entry point that gets me authenticated rights, not admin, nothing particularly interesting, but I'll then use that to escalate. I'm going to get that to domain admin, or maybe local admin. I've actually had success pwning multifactor with only local admin on a small number of machines, if those happen to be the machines that are useful for you. But I want some kind of admin rights. Then I'm going to find the users that access the PCI network, in this case, and then I'm going to target them specifically, get the credentials that they use, so I can log in to the boxes that give access to the special zone that's separated from the rest of the environment, and then I'm going to compromise the CDE. And that constitutes my success criteria for the pen test. So in PCI, there's this interesting thing that changed a little bit with the 3x standard, a little more verbiage on segmentation. They really have to segment that area so that even if something outside the PCI zone is compromised, it doesn't impact the security of the PCI zone, which means my pen test there is a PCI problem, because all I have to do is vertically escalate inside and hop directly into the CDE. So the customer looks at that, and they say, gee, I've got to find some way to stop that, and I can't control my internal network enough to keep you from getting that vertical escalation. You guys get admin every year. So this is kind of a natural fit for multifactor, because now you can say, heck, I'll give you all the passwords, and having those, you still can't get in because you don't have the hardware device. So now let's think about what the pen test looks like with the MFA. I'm going to find some low-hanging fruit. I'm going to escalate that to domain admin, find the users that access the CDE. I'm going to use that to somehow magically, with pixie dust or whatever, pwn MFA, log in, and achieve my success criteria. And what I want you to see is that in context, in a real breach, this is the situation where I'm going to attack multifactor on the internal network. This isn't relevant so much to trying to get through the VPN login from your Starbucks Wi-Fi or something like that. There are other MFA scenarios to think about. But on the internal network, when you're protecting a special area from the rest of the untrusted environment, this is how it looks. And there are a few things that I have. There's only one little difference between these two pen tests, but this is what I've got. I have probably domain admin. I probably can keylog or observe what the users are doing on their workstations. And I have plain text passwords. I know actually what they are. And even if they're really complicated ones, once I'm admin, Mimikatz gets me whatever I want, which is the pen tester's best friend. And I have access to the workstation that's going to access something through multifactor. So attacking MFA directly, like I said before, if I'm looking for that O-Day against MFA, it's going to be hard. And a lot of that is because of cryptography. You've got pseudorandom number generators with seeds. You've got handshakes, all kinds of interesting things that are out of my pay grade for a 3-day pen test. But as a pen tester, what I'm looking for is something that gets me past MFA, and I don't necessarily have to beat the MFA design itself. If I can just find a way to circumvent it or get around it, I'm happy with that. So it's time to go through a couple examples. This is what I can fit in the talk. There are a few more. I got like 8 or 10 scenarios I'd love to go through, but these are the two that I think are going to work the best for the Prezo. The first one I'm going to talk about is RSA Secure ID. So Secure ID, which I assume most people are going to be relatively familiar with, is where you have a little fob, put that on your keychain. There are also soft tokens and some other ways of doing it, but basically this gives you a second factor in addition to your password. So the procedure for the user to log in to, in this case, a remote desktop service, you can attach this to other services, but for the presentation, I'm going to talk about the RDP scenario. This is what it looks like. We're going to type in our username. We're going to type in the password, or passcode, sorry. It's a value that goes right in front of the 6 digits. And we wait for our next token value because we got to get that at the beginning. If we don't, we'll type one in earnest, and then it won't work because it'll rotate. We'll type in our second factor, which is that 6-digit code on the fob. Wait for the prompt after that because it hopefully works, and we type in our AD password, and we get remote desktop access. And when I look at that, first time I came up against this and really, really, really wanted to beat multifactor, I didn't want to just say, oh, you guys have multifactor, you win. I noticed something about this process that was very interesting and suggests to me that there's a way that we can attack this thing. And that's the use of the word type in a lot of places. You notice especially that there are 2 things we type that are critical to multifactor. We type the second factor first, ironically, and then we type the first factor, the AD password. And if you remember from our scenario, I'm already admin and I own the keyboard. So I can observe the keyboard and I can manipulate the keyboard. I can inject keystrokes, I can respond or take action when certain key sequences occur, and that gives me an opportunity to attack secure ID in this case. So the way the attack works, this is an example from a real pen test. I've done this a number of times at this point, myself and other guys on our team. The first thing I do is I look at the resource that I'm going to log into. I want to understand exactly how it works because different versions of Windows log in a little differently. Sometimes you have to press Control-Alt-Delete before you can get the prompt. Other times you might have a legal disclaimer or something like that. Don't hack this system or you'll get in trouble. And I want to make sure that I understand exactly how this is going to work. Even though I don't have that second factor, I need to understand it very carefully because I'm going to write an automation script. And what this does is I assume in the script that at some magic moment, I have the 6-digit value. I know the user name, I know their password, and I have a 6-digit value that's going to work for a short period of time. If I have that, this script will automatically log in for me. It's going to start a remote desktop. It'll wait 3 seconds. It'll press enter. These guys had 2 enter screens. So I had to wait another 2 seconds and press enter again. And then I type in the username, press tab, etc. This just automates the login process. So the next thing I do, can't use the right arrow key. Next thing I do is I install a keylogger on all of the target users. So I've figured out which users usually make network connections to the CDE or something like that. I might have 100 or 200 users that I'm targeting. So I installed this, and this is an in-house keylogger that I put together for this attack. This one I can harvest from a large number of machines, and it's instrumented with attack modes specifically for Secure ID, where I can instruct all of the keyloggers, start watching for 6-digit codes. If you see a 6-digit code, let me know. And when they find one, they notify my admin console and say, hey, I think I found one. So here's an example. Sometimes there are false positives. If somebody's editing a spreadsheet, for example, or maybe they're coding and they might type 6-digit numbers for other reasons. So it's good to look at it. But this one looks pretty obviously like a login. We can see that this guy's passcode that precedes the 6-digit number is 7654321A, which I thought was hilarious. Anyway, followed by 804027, so that's his 6-digit value. He presses enter, and then following that is something that looks very suspiciously like a password. And you get 2 guesses about when I took this screenshot. Once I clearly identify that, I can instruct his keylogging agent to switch modes, and I tell it, now I know what this guy's passcode is. Next time you see a 6-digit number preceded by that passcode, jump into action, and we're going to compromise it. So the way that looks is, I wait some time, maybe his remote desktop window locks and he has to unlock it. Maybe he goes to lunch or something, he comes back, has to log back in. Could be a couple hours, whatever. Next time he logs in, the keylogger detects that, and then it sends a message back to the keylogging server. And it says, I think we've got a case where we know what the 6-digit value is. And it takes a special action at this point. What it does is it kills the mstsc.exe process. And so what the user experiences is he dutifully puts in his code, waits for the thing to show up on his token, types that in, and at the moment of the 6th digit keystroke, his window disappears. And sometimes I used to be really concerned about possibly getting detected by a user in this situation, but in real life, what users do is they say, I hate this computer, it's so slow, I wish they'd give me a better one, this always happens to me. And he'll try again, because he figures he never hit enter, never clicked OK. So you can see that he tries again with the same code, but it doesn't work. And that's because I used the code. And so he tries a 3rd time and finally gets it, and that's with the next code on his token. But in the meantime, I now have my remote desktop window because I've stolen his session. And you might think, well, with remote desktop, won't he just steal my session back? It turns out in a lot of places they'll have more than one jump box. Also, and I'll give you an exaggerated case of it later, even having this desktop for a short period of time is useful enough. But at this point, I'm in a really good position to solidify my control of that cardholder data environment, because I've circumvented MFA one time, but now I can look for a persistence vector. I can try to find a way, can I communicate back out from that box to my machine and get persistence that way? Can I connect to the public internet? Can I ping? Maybe I can tunnel it through ICMP. I'm trying to find some way that I can sustain my access now, and I never have to hack MFA again. So it's a one-time thing in the typical scenario. So what's fun about this is it's not really a vulnerability in Secure ID. And I'm sorry, was that the 10 minutes? Cool. So it's not necessarily a flaw in Secure ID. The number generation works fine, and I didn't compromise that. I didn't get his seed. I didn't guess his seed, anything of that nature. What it really is as far as RSA is concerned, this is a time where the user needs to secure their endpoint. And any guesses how hard it is to secure an endpoint so that a domain admin can't do this? It's really, really hard. Been to some places that are running top-tier defensive tools, and unless you're particularly careful, this ends up working quite well. You use an unknown keylogger, be willing to adapt it or something in the process. And what this means is that this kind of attack kind of will always work, probably. In any case where you've got this keyboard-focused multi-factor. It's good to mention, too, Secure ID is not the only one. There are a number of other token-based systems. There are mobile-based systems where you still type the code in. So you can adapt this same design or this strategy to work in a lot of cases. But you might say, that's not how all multi-factor works. So what if we're using a multi-factor design that doesn't really rely on the keyboard? And those do exist. I'm going to give you one fun example of it, and that's Duo. Anybody heard of Duo? Cool. That's a ton of hands raised. I use Duo. I have Duo for a couple different things. And Duo is really neat. It has the 6-digit number thing, but you don't have to use that. You can force your application to do a mobile push. And so what it looks like when the user logs in is they authenticate with their normal Active Directory credentials. And then they wait for a mobile push, and it shows up on the phone, and they authorize it there. So there's no second factor going in through the same channel as the first factor. So this type of MFA requires a fundamentally different strategy. And when I looked at this, I stepped back and thought about this process. There's one little word up there that kind of sticks out as a little beacon that says maybe there's a way to attack this. And it's a question that gets raised by that word wait. What happens between the moment when I type in my password, I should say password, sorry, and the moment when I authorize it on the phone? And there's an interesting race condition in Duo where if you have two concurrent push notifications going to the phone, only one of them appears. And any guess which one gets authorized? It's always the second one. If it was always the first one, it's still a vulnerability. If it was random, you just try a couple times and eventually you'll get it. At any rate, the compression of those push notifications makes it very interesting. So I'm going to show, hopefully, a video here. This is very awkward. There we go. So on the left, we've got a user who's going to log in with Duo to a multi-factor resource. And you know what? That is unsatisfactory. Hopefully we'll make this work. So then over on the other side is my machine, and I'm going to establish a shell. Remember, I have admin. I just want to get into that CDE. So I'm going to create a service, which is just a custom malware that I built that monitors the behavior of the user. And what it's looking for is that moment where the push notification is going to go out. And then also, at the end here, hopefully you can see it, I have a network service at the bottom where once I start that service on the victim's machine, I now have a network component on my side that's going to wait for the signal that tells me that MFA is about to happen. So now, over on the victim side, the user is going to log in. What was really interesting in this case is how do you tell when the push notification goes out? It goes out when the desktop session is created, which also corresponds exactly with when remote desktop uses more than 27K of memory. So all I do is watch for network connection out to 3389, and whenever that memory usage goes over 27K, that's my signal. So we can see over here, on the left, we've got a pushed login request to my device. And then on the right, you can kind of see it down in the corner, it says receive the command, and it's making a connection. We'll see, come on, click. Where is it? There it is. So we'll see that now we're in the race. We got 2 notifications going out. The user authorizes it, and it's mine that wins because I was the second one out. And what happens on the left side is the user will time out. It'll take about 60 seconds, which gives me minimally a 60-second window where I could, for example, download a PowerShell one-liner that installs my remote agent, and then he won't even know once he steals the session back. But then usually there's going to be more than one box that I can log into. So I log into the second one, he logs into the first one, and I've got it. So, thank you. So we talked to Duo about this because this is actually kind of a vulnerability. And so they released a feature earlier this summer that allows you to detect the double push and prevent that from working on the client side. The hard part is it affects the user experience, and there are actually times when Duo legitimately does a double push. Apparently, we found out in conversation with them. So it ends up being an opt-in feature, which means that every time I go somewhere that uses Duo, I'm going to try it anyway, because if they don't have that turned on, they're still vulnerable. There are a lot of places that would consider this type of attack not a huge risk. They'd say that's kind of exotic and elaborate, and if they're going to try that hard, they can have it. But for places where you've got your CDE or something that's highly critical protected with MFA, this might be of concern. So you want to make sure if you're running Duo, check that out. Make sure you have that turned on. So attacking MFA in PCI environments like I'm talking about, and probably similar environments as well, usually comes down to client-side attacks or timing attacks, race conditions. The Duo one's a race condition. And they all have a similar character. They're going to be some sort of probabilistic success scenario. They work sometimes, not all the time. It's not like MS 08067, where it's just fire and forget. On the other hand, if you think about it, like say the user backspaces while they're typing in their passcode or something, and my keylogger doesn't trigger, it's really not that big of a deal because it doesn't cause a problem, and I just wait till the next time they log in. So in real life, these work very reliably. It just takes time. And I find that it's usually, by the time I get to the position to launch this attack, it's probably a couple hours before I get one of the MFA sessions stolen like this. So it really does work quite well. And in my failing time here, we can't talk about it without a little bit of mitigation. If you're concerned about these types of threat scenarios, what do you do? Major point, I think, is it's really easy to attack those in-channel second factors. I don't want to say out of band, because a lot of people will consider the 6-digit code generator to be out of band, but it's not out of channel because the second factor is delivered in the same mechanism that uses the first factor. So an out-of-channel design, kind of the Duo type approach, there's some others like that, is much more interesting. You get the ones where it sends you an SMS and you reply to it or something like that. Those are a lot harder to attack. And then secondly, if you can't do that, then harden the endpoint. It is very difficult, but it can be done. Your main goal is to stop remote code execution. If you can keep your admins from running code on the workstations, and you can imagine things like local firewalls, very restrictive policies, maybe some defensive tools like Bit9 or something like that that lets you more strictly control execution, it is possible to do that. And then finally, train the users. I have watched, because I'm keylogging, I've watched a conversation with a guy and his IT support saying, it failed on me, and I've never seen it fail that way before, because he was a particularly anal retentive user. And they end up diagnosing it as a network glitch, because computers just do that sometimes. So it's actually quite rare for something like this to be even seen as a security event. And frankly, it's going to happen once or twice in the breach. So it's not like you're going to have a bunch of data points. People say, oh, lots of people are failing their MFAs today. It's not like that. So you should train people that are accessing a highly critical resource that any kind of funny glitch could potentially be a security event. So with that, I think I have very little time for questions, maybe one question. Sure.
I didn't see the label on the Duo feature that you were highlighting.
Oh, yeah. So if you go in, hopefully, if you look in under lockout and fraud, there's a checkbox that says block anomalous Duo push attempts. So they did post a blog post about it. That's terrible grammar. They created a blog post about it earlier this summer, and so you can find some information about that there. They didn't want to create a CVE or anything because it's a cloud-based service and they applied it. But it's important that people understand that that is there and it's available if you care about the scenario. So, all right.
I know you had said that there was probably 8 of them.
Thank you. And there are other scenarios, really, really fun stuff I just couldn't fit in. So if you want to chat more, grab me afterwards. It'll be fine.